Problem number 21. A syringe is filled with water of density ρ and negligible viscosity. Its body is a cylinder of cross-sectional area A1, which gradually tapers into a needle with cross-sectional area A2 much less than A1. The syringe is held in place and its end is slowly pushed inward by a force F, so that it moves with constant speed v. Water shoots straight out of the needle's tip. What is the approximate value of F? Problem number 22. A spherical shell is made from a thin sheet of material with a mass per area of sigma. Consider 2 points, P1 and P2, which are close to each other, but just inside and outside the sphere, respectively. If the accelerations due to gravity at these points are g1 and g2, respectively, what is the value of absolute value of g1 minus g2? Problem number 23. Collisions between ping-pong balls and paddles are not perfectly elastic. Suppose that if a player holds a paddle still and drops a ball on top of it from any height h, it will bounce back up to height h over 2. To keep the ball bouncing steadily, the player moves the paddle up and down, so that it is moving upward, with speed 1 meter per second whenever the ball hits it. What is the height to which the ball is bouncing? Problem number 24. When a projectile falls through a fluid, it experiences a drag force proportional to the product of its cross-sectional area, the fluid density ρf, and the square of its speed. Suppose a sphere of density ρs much greater ρf, of radius r is dropped in the fluid from rest. When the projectile has reached half of its terminal velocity, which of the following is its displacement proportional to? Problem number 25. A yo-yo consists of 2 massive uniform disks of radius r connected by a thin axle. A thick string is wrapped many times around the axle, so that the end of the string is initially a distance r from the axle, then, the end of the string is held in place and the yo-yo is dropped from rest. Assume that energy losses are negligible, and that the string has negligible mass and always remains vertical. Below, we show a cross-section of the yo-yo partway through its descent, between the moment the yo-yo is released and the moment the string completely unwinds. Which of the following is true regarding the yo-yo's acceleration? Answer: A. It is always 0. Answer: B. It points downward, but decreases in magnitude over time. Answer: C. It points downward and has constant magnitude. Answer: D. It points downward, but increases in magnitude over time. Answer E. None of the above.